the wind shifts over vast oceans. The sky darkens with the falling dusk, and somewhere above the clouds, a bird is flying. It doesn't stop to ask for directions. It doesn't carry a map. There's no glowing screen guiding its wings, and yet it knows exactly where it's going. From the frozen tundras of the north to the warmth of the tropics. From the same tree it was born in, to one it has never seen before. Somehow, this fragile creature weighing no more than a few ounces traverses thousands of miles across continents, oceans, and time zones. But how? How do birds migrate? Without maps, without GPS, without anyone telling them which way is home. Tonight, we drift into the mystery, into a story written in feathers, winds, stars, and magnetic fields. Into a biological compass, hidden inside tiny beating hearts. This is not just a bedtime story. It's a flight into one of nature's most incredible wonders. One you've seen from your window, but never quite like this. You're watching science for sleep, where we let your mind wander gently through science, until your body slips into peaceful rest. Before we take off, let us know where in the world you're watching from tonight. Like this video, if you find comfort in curiosity, and subscribe for more.com, poetic science journeys, designed to help you drift into sleep, with a head full of stars and a heart full of wonder. Now, let us follow the wings. The sky is a highway without signs, a vast and open path without painted lines or toll booths. Yet every year, in perfect rhythm with the turning of seasons, millions of birds take flight as if they've memorized every cloud, every breeze, every path the sun will take across the horizon. Tonight, we begin with this mystery, the great migration, not just of one bird, but of billions. From tiny warblers that could fit in your palm to long-winged shorebirds flying from pole to pole. The skies become filled with ancient motion, a global dance few of us ever truly notice. Close your eyes and picture a world map stretching across the night. Now imagine that map, glowing with threads of motion, lines of light tracing, invisible highways from north to south and back again, from Siberia to Africa, from Alaska to Argentina, from Canada to the Caribbean. These are the flight paths of life. Some birds fly for weeks without stopping. Others take short, familiar hops from forest to field, guided by the scent of home and the memory of places they've never seen. Each feathered traveler obeys a clock we cannot hear, a calendar not printed but felt, a pole written deep inside their cells. The Arctic tern, for instance, is no larger than a dove, yet it migrates from the top of the earth to the very bottom, and then back again. Over 40,000 miles a year, a journey longer than the circumference of the planet. It sees 2 summers every year, flying from the polar day in the north to the endless light of the south dot. Why? Not because it's fun, not because it's lost, but because something deeper calls, a need to survive, to feed, to breed, to return to a place that once cradled its eggs in warmth. And it's not alone. In every corner of the world, migrations happen, silently, invisibly, faithfully. A hummingbird may cross the Gulf of Mexico in a single flight. A sandpiper may touch down on just a few windswept islands across the Pacific. Swallows return to the same barns each spring. Storks return to chimneys. Swifts may stay in the sky for months, sleeping as they glide. They do not choose these paths randomly, nor do they guess. They know. And that is the question that brings us here tonight. How do they know? There are no signs, no training, no one telling them turn left at the Alps or go south at the Rockies. Many hatchlings migrate before ever meeting their parents. They are born with directions already whispering through their blood. A newborn human cannot walk. A newborn bird may fly halfway across a continent in its very first year. This is the kind of intelligence that doesn't look like thinking, but it is. It's a kind of wisdom etched into wings, a memory stored not in stories, but in molecules. When scientists placed migratory birds in planetariums and shifted the stars above them, the birds adjusted their orientation. When they blocked the Earth's magnetic field, the birds seemed lost. When they manipulated smells in the air, the birds turned in unexpected ways. What does that tell us? That birds navigate with more than one compass. They use many layered on top of one another, a toolkit for survival, built by millions of years of flight. Some follow magnetic fields. Some use the angle of the sun. Some memorize the smell of rivers, forests, or mountain air. Some feel the wind in a way we never will. Some hear the infrasonic rumble of waves hitting distant coasts. They are flying scientists. Their instruments are invisible, but precise. And through these instruments, a chick born in a forest in northern Canada can find its way to a tiny patch of forest in Brazil, a place it has never seen but is always known. What does this mean for us here tonight? It means that the world is full of knowledge we do not see. It means that nature remembers, and it means that the sky above your head right now may hold travelers passing over your home as you lie in bed, birds on their way to places far beyond your dreams. So tonight, as you breathe softly, imagine what it feels like to be one of them. You are no longer in a room. You are gliding on cool night winds. The stars above are your map. The air below tells you where you are. There is no road, but there is a direction, a pull, a promise, a home on the other side of the world. And somehow you know exactly how to get there. Let the quiet wisdom of wings settle into your breath, and as the story unfolds, we'll begin to unravel how this miracle works, because birds may not have GPS, but they do have something far older, far deeper, and far more wondrous. You lie in the stillness of night, your breath gentle, your body slowly softening into rest. Above you far, above where even dreams cannot climb, wings beat softly against the high air. A swallow crosses a continent. A plover streaks silently over sea and cloud. And not one of them has a map. Asterisk, no paper, no screen, no satellite signal. But they don't need them because something inside them already knows. This is not a metaphor. They carry the world inside them. Literally, tonight, we descend into the bird's mind. Not the mind, as we imagine it, of worries and words, but the part wired for direction, for motion, for the great, invisible pull of Earth itself. Inside a bird's brain lies a tiny region, known as the cluster N. It's not a place of thoughts, but of orientation, a compass that lights up when birds view stars or sense magnetic fields. It glows with activity when they look to the skies at night. When they tilt their heads and scan the heavens, it's as if their brains are listening to the stars. And during migration season, cluster N becomes hyperactive. It burns with purpose. When scientists placed migratory birds into planetariums with simulated night skies, the birds didn't panic. They turned, shifted, reoriented themselves based on the stars projected above them. They knew the stars weren't real, and yet their instincts couldn't resist recalibrating. Why? Because their brains treat the sky like a living map, and that map is etched so deeply, they begin studying it as hatchlings. Even birds born in captivity, who have never seen a night sky, still turn in the right direction during migration season. Something in them points the way. This internal compass isn't just a vague feeling. It's tied to measurable, physical structures in the brain. The hippocampus, a part of the brain used for memory and navigation, is often larger in migratory birds than in sedentary ones, especially during migration season. Imagine your own brain growing a little bigger every time you plan a trip. That's what happens to birds, except the trip is thousands of miles, and the memory is not of places they visited, but of paths written before they were born. It's not just about memory, though. It's about magnetism. Scientists discovered that birds can detect Earth's magnetic field, not just directionally, but intensity, inclination, and location. It's as if they have a sixth sense, one tuned to the quiet. Invisible lines that stretch from pole to pole. In fact, there's evidence that birds may see magnetic fields as subtle patterns overlaid on their vision, a kind of shimmering guide, a glow we cannot detect. Imagine looking out at the landscape and seeing a gentle curve of light nudging you left, another sweeping you right. Not a voice, not a map. Just a quiet nudge in the right direction. This is what many birds may experience. But how? One hypothesis involves cryptochrom's light-sensitive proteins in birds' eyes. These may respond to Earth's magnetic fields, creating faint visual cues tied to magnetic direction. Another involves magnetite, tiny crystals of iron oxide in the upper beak or inner ear, acting like miniature compass needles. Either way, the result is the same. Birds know where to go, not by looking outward, but by listening inward. Even more extraordinary, many birds combine multiple systems. They learn landscapes. They memorize star patterns. They detect smells. They notice temperature shifts. They feel wind direction, and they track the sun's arc throughout the day. Some even use polarized light, the subtle angles at which sunlight scatters in the sky to determine where they are on Earth. Even when the sun itself is hidden behind clouds, this isn't magic. It's biology, and it works. Let's follow the bar-tailed godwit, a plump, short-legged shorebird. It flies from Alaska to New Zealand in a single, non-stop journey, over 7,000 miles of open ocean. No land, no landmarks, no rest, and it never misses. Its brain calculates fuel needs, predicts weather patterns, waits for the right wind, and launches when the sky aligns. How does it know where to go? It doesn't. Think about it. It remembers in a way far deeper than logic. Its brain, its cells, carry the imprint of generations before it. Each year, juvenile godwits who have never flown the route before depart alone and still arrive at the same estuaries. In New Zealand, their maps are not written. They're inherited, and their GPS, etched in neurons. Other birds add experience on top of instinct. The white-crowned sparrow, for example, learns its migratory route by following older birds. But once it learns, it can make the journey alone. In darkness, without landmarks, without getting lost, even when displaced moved hundreds of miles off course, birds often correct their path and still arrive at their destination, not just directionally, but geographically. They seem to know where they are and where they're going at the same time. This dual awareness of place and motion is something few creatures can replicate. Humans need GPS, maps, street signs, guides, but a bird simply lifts off and lets its body remember. You might wonder, can this sense be lost? Yes, birds raised under artificial light, in distorted environments, or with magnetic interference, can become confused or disoriented. It shows how delicate the balance is. These navigation systems are ancient, but not invincible still. They're resilient. Migratory birds today face shifting climates, city lights, and expanding buildings. Yet many still find their way, still follow the invisible threads of the earth, and it all begins in the brain. A brain tuned not to television or traffic, but to the deep pulse of planet and sky. So tonight, as your own thoughts drift like circling feathers, imagine your brain lit by starlight. Imagine carrying a map, not on your phone, but in your bones. A quiet certainty that tells you, this way, you're not lost, even in the dark. Even when you've never been there before, because somewhere inside you, as in every bird, there's a memory older than memory, a map etched not in ink, but in light, in magnetism, in the soft pull of the horizon. And though you may never need it, it is comforting to know we were not the first to find our way without a map. We learned it from wings, somewhere, deep within a bird knot in its wings, nor its eyes, nor even its brain, but in the quiet chambers of its chest. There lies a compass made not of metal or glass, but of instinct, of magnetism, and the slow rhythm of evolution. As you rest tonight, feel the steady rise and fall of your own breath, your heartbeat like a drum in the dark. Now imagine a heart, much smaller, faster, feather-wrapped, beating beneath a sky filled with stars. Inside that tiny chest is something astonishing, a sense not quite like smell or sight, but a biological ability to feel the pull of the earth itself, to sense direction in a way that humans once dreamed of, but never fully owned. This is not magic, it's magnetoreception, a scientific word for something deeply ancient. Birds can detect the Earth's magnetic field, and they use it like a traveler uses the North Star, or a sailor follows the horizon to find their way across oceans, continents, and cloud-laced skies. But this sense isn't found in their eyes or ears. It's felt deeper. Some researchers believe the key lies in the trigeminal nerve, a delicate pathway that connects their beak and brainstem. Others look toward the inner ear, or two specialized cells laced with magnetite, tiny iron-based crystals that may act like biological compass needles, aligning with Earth's magnetic field, pointing north, pointing home. And this is just the beginning. Imagine you're a warbler, only a few ounces in weight, setting out from Canada to fly all the way to South America. No map, no compass, no phone, just the wisdom carried in your blood, and this strange silent feeling that north feels like one way and south another. This compass doesn't work like a tool you hold. It's more like a feeling that whispers, this way, keep going, trust the pull. Birds don't sit and analyze routes. They don't plot coordinates. They surrender to something deeper, a choreography between body and earth. Even newborns, those who've never flown before, can sense the way south during autumn. No one teaches them. It's written in their biology, as if the planet has inscribed its directions inside their skin. And it's not just direction. Some birds can sense magnetic inclination, the angle of the Earth's magnetic field that tells them where they are, not just which way to go, but how far along the globe they've flown. A sandpiper may use this to cross the open ocean. A pigeon may find its coop hundreds of miles from where it began. A swallow may return to the very same eave of the very same barn after flying halfway across the world. As you close your eyes, let yourself feel what that kind of knowing must be like, to trust the earth itself as your guide, to let invisible lines drawn by magnetism shape your entire journey. And here's the wonder. This compass isn't infallible. Storms, solar flares, even radio towers can interfere. And yet, most birds still find their way, as if their entire being bends toward a destination they can't yet see. But somehow, remember, the compass inside their chest doesn't hum or beep or glow. It doesn't point with arrows. It pulls quietly, steadily. And the bird responds with flight. Scientists still don't fully understand how it works. It's one of biology's great mysteries. We have theories, experiments, models, but the lived experience of a bird in flight remains largely unknowable. Perhaps that's the beauty of it, that even in a world filled with satellites and data, some creatures still travel using forces we can barely explain. And yet, they do it again and again, across mountains, deserts, oceans, and snow. In the dark, on overcast nights, when stars are hidden and wind swirls wild, that inner compass keeps beating, keeps guiding, keeps pointing them home. Just like your own inner sense of rightness, of where you belong, of when it's time to move, and when it's time to rest. So tonight, as you lie still, let that be your lullaby, that there is a wisdom in small things, a compass in the chest, a pull toward home that needs no map, no signal, no light on the screen, only trust, only time, only wings, and the will to follow the way. Imagine walking through a vast, featureless plain in total darkness. There are no stars, no wind to guide, smells, no sounds, no familiar trees or buildings. Just blackness in every direction. And yet you keep walking, not by chance, not by guessing, but because something inside you knows which way is north. This is the mystery of the magnetic sense. Birds, with their small bodies and beating wings, carry within them one of nature's most subtle superpowers, the ability to feel the Earth's magnetic field, not just to detect it, but to use it like an invisible map, like a GPS hardwired into their biology. How do they do it, and why is it so important? Tonight, we go deeper into the secret that allows birds to fly halfway around the planet without getting lost. No compass, no satellite, just a quiet awareness of a force that flows all around them, all the time. Earth, a planet wrapped in magnetism, the Earth is more than land and sky. It is, in a very real sense, a giant magnet. At its core is molten iron, spinning slowly and creating a magnetic field that stretches far beyond our planet's surface. This field protects us from solar radiation, but it also provides a kind of scaffolding, unseen framework for navigation. Humans can't feel it. We need compasses or machines, but birds, they feel it. They sense it. They live inside it, the way fish live in water. A sixth sense for decades. Scientists suspected that birds used the magnetic field to navigate, but the big question was, how? The answer came in pieces. Some discoveries pointed to special proteins in birds' eyes called cryptochromes. These light-sensitive molecules respond to magnetic fields, not by pulling or pushing, but by affecting the bird's vision. Yes, their visions. Their vision. Imagine looking at the world and seeing an overlay like a shimmer, or a shadow that tells you which direction is magnetic north. Not with your thoughts, but with your eyes. Robins, for example, seem to rely heavily on this light-dependent magnetic compass. In experiments, they navigate best under certain wavelengths of light, especially blue and green. When the light changes, their sense of direction becomes confused. It's as if their internal compass is tied directly to their ability to see that. This magnetic vision might show them patterns or gradient subtle changes in the field as they move across the Earth. These patterns help them understand not just direction, but position, like reading the gentle slope of a hill, but in invisible energy. The iron in their beak spot, that's not the only magnetic trick birds have. In many species, researchers have found tiny particles of magnetite in their beaks. Magnetite is a naturally magnetic mineral, a kind of biological iron. These particles are thought to act like miniature compass needles, aligning with Earth's magnetic field. These signals travel through the trigeminal nerve to the brain, giving birds a sense not just of direction, but of where they are, like a built-in map. Some birds seem to rely more on the beak system, others on the eye. Still others might combine both. Imagine if you had two GPS systems in your body, one in your eyes, showing you magnetic direction as a color, and one in your jaw, whispering your global coordinates. That's the level of complexity birds carry on their migrations, feeling the field it. It's not just about finding north. Earth's magnetic field varies by latitude. The strength changes. The angle of the field lines tilts, depending on how far north or south you are. Birds appear to use these variations to figure out their location even when they're flying over the middle of an ocean, with no land in sight. In other words, their magnetic sense gives them both a compass and a map. This ability is especially useful at night, or in bad weather, when visual cues disappear. When the stars are covered or the sun is low, the magnetic field is always there, always steady, always true. It's the one constant they can trust. Testing the sense. How do we know all this? Through years of careful experiments in labs, scientists exposed birds to altered magnetic fields and watched how they responded. Some birds were placed in magnetic coils that tricked them into thinking north was in a different direction, and they turned to follow it. Others had their trigeminal nerves temporarily blocked. Suddenly, they couldn't figure out their position. It was like scrambling the data in a GPS device. These tests showed that birds rely deeply on magnetic information. It's not a backup plan. It's a core part of how they migrate. Magnetic memory perhaps even more extraordinary. Birds seem to remember magnetic landscapes, just as you might remember a familiar street corner or skyline. Birds may remember the magnetic signature of key places along their route as they fly over mountains or valleys. They're not just seeing landforms, they're feeling magnetic patterns that mark their progress. This memory helps them return to the same breeding grounds year after year, even if those places are thousands of miles away. A journey in layers. By now, you can see that migration isn't guided by one system. It's a layered process, a choreography of senses. Birds use the sun and stars, wind patterns, smells, sounds, landmarks. But through it all, threading quietly beneath the surface, is magnetism. It never sleeps, it never fades, and birds never stop feeling it. As you drift off tonight, let your mind imagine that invisible web lines of energy stretching from pole to pole, circling the globe, each one a silent guide, each one a path for wings. No map, no road signs, just the planet itself, speaking in the language of magnetism and the birds. Listening, always listening, with every beat of their feathered hearts. Close your eyes and picture the sky at night fast, quiet and scattered with stars. Now imagine you're a bird, thousands of feet above the earth, wings outstretched, navigating in silence. There are no road signs up here, no glowing streetlights, yet you know exactly where you're going. Not by chance, but by the ancient guidance written across the sky. Birds are nature's celestial navigators. They have learned to read the sky the way you might read a story, carefully, instinctively, page by page. This chapter dives into the remarkable way birds use the stars, the sun, and their own internal sky clock to journey across the globe without maps or GPS. By the light of the stars, for centuries, humans have watched birds vanish into the horizon and wondered how they find their way. It wasn't until the 20th century that scientists uncovered something spectacular. Birds can use the stars to navigate. In 1957, a scientist named Stephen Emlen conducted a infamous experiment using indigo buttons. He placed the birds in a planetarium where he could control the night sky. When the stars spun in the correct, natural way, the buntings oriented themselves in the direction they would normally migrate. But when Emlen rotated the stars, unnaturally, the birds became disoriented. What this proved was breathtaking. Birds weren't just reacting to light, they were reading patterns. They could map their position based on the rotation of constellations, especially the North Star and those surrounding it. Just as sailors once used the sky to guide their ships, birds use constellations as a celestial compass. And remarkably, they learn this by watching the stars during their early life. It becomes part of their internal navigation system, etched into their memory like starlight on water. The sun as a daytime guide, while stars guide nighttime travelers. What about birds that fly during the day? That's where the sun comes in. Birds have an extraordinary ability to use the sun's position as a compass. As the sun moves from east to west throughout the day, birds adjust their orientation. But this alone isn't enough. The sun changes position depending on the time. to use it effectively. Birds need an internal sense of time, and they have it. The sky clock. This brings us to one of the most fascinating features of migratory birds, their internal circadian rhythm, or what scientists often call the sky clock. Deep within a bird's brain is a biological clock that keeps perfect time. It tells them when the sun should be in the sky and at what angle, by comparing the sun's current position to their internal clock. Birds can determine direction. For example, if the sun is low in the east and it's morning, according to their inner timepiece, they know they're heading south if the sun is on their left. Later in the day, that same sun will be behind them. Experiments have shown that when scientists disrupt a bird's internal clock by altering light cycles, for instance, the bird's sense of direction also changes. This proves how deeply their navigation is tied not just to the world around them, but to the rhythm ticking inside. Sky patterns and weather wisdom birds don't just rely on the stars and the sun individually. They integrate multiple sources. They combine stellar cues, sunlight, wind patterns, and even barometric pressure. This gives them a layered, resilient system that can adapt to cloudy skies, stormy winds, or changing seasons. When stars are hidden by clouds, birds turn to wind direction or geomagnetic fields. When the sun is blinding or blocked by haze, they fall back on celestial memory, in a way. They're constantly recalculating, like a living GPS that triangulates direction from 1,000 moving data points. But this system doesn't require satellites for updates. It was perfected through millions of years of migration. Born with a map, taught by the sky. Some birds are born with an innate map of where they should go, but just as important is their ability to refine that map by reading the sky. It's learned, it's practiced, and it becomes second nature. Juvenile birds on their first migration will often fly alone, relying on instinct. But once they've seen the stars, once they've watched the sun rise and set during flight, something inside them clicks. They remember the feel of direction, the arc of daylight, the angle of twilight, the universal language. Above perhaps what is most humbling about this system is that it works the same all over the world. No matter where a bird begins, its journey, the Arctic tundra, the African plains, the forests of Asia, the sky speaks the same language. North is always north. The stars always rise and spin in predictable ways. And so, a bird from Canada can fly to the Amazon. A tern can journey from pole to pole. A warbler can return to the very same tree it left 6 months before, all because of the ancient glowing map above their heads. As you drift into rest tonight, think of this. High above you, a bird is gliding in darkness, reading the stars the way you read dreams. It is not lost. It is exactly where it should be guided, by a clock older than time, by stars older than memory. In the vastness of the sky, there is no loneliness, only direction, only wonder, only wonder. The sky is not silent. It whispers in currents of wind, dances in fragrances on the breeze, and hums with low, distant calls. For birds, these subtle signs are not mere background noise. They are navigational instruments. Each gust, each scent, each sound plays a part in a centuries-old migration symphony, guiding wings across continents without the need for maps, compasses, or GPS. Let's follow the wind, High above the land, winds form invisible rivers. These air currents vary in speed, direction, and altitude patterns shaped by geography, seasons, and atmospheric conditions. Migratory birds, especially those that travel long distances, have learned to read these currents. They soar into tailwinds that carry them forward with little effort. They climb to altitudes where the air is smoother and the flow more favorable. They wait on branches or shorelines for just the right breeze, knowing that the winds can be a friend or a foe. It's not just about going with the flow. Some birds, like the alpine swift, can detect subtle changes in air pressure and humidity, using this sensory data to anticipate weather shifts. They make micro-adjustments, rising, gliding, or changing course to ride the sky's hidden highways. The wind is more than air, it's a dynamic compass. Now shift your attention to scent. The notion of birds having a strong sense of smell was once dismissed, but new research tells a different story. Birds like the European storm, petrel, and the pigeon possess olfactory powers that rival those of dogs. In coastal species, the ocean's scent landscape is a blend of phytoplankton, fish oils, and salt. Storm petrels can locate feeding grounds by smell alone, even from miles away. Land birds use scent trails too. Some pigeon species rely on familiar smells, drifting on regional winds to sniff their way back home. Even migrating songbirds may detect the subtle fragrance of forests or wetlands long before they see them. Scents act like invisible signposts, connecting a bird's memory to the world's geography. Then there's sound. The world hums with low frequency. Vibrations, thunderstorms, rumbling over distant mountains, waves crashing on faraway shores, even the low tremors of tectonic plates. Some birds, especially pigeons and doves, are known to detect infrasound, which travels for thousands of miles. These deep sound waves, far below what human ears can detect, provide orientation cues across great distances. Migrating birds also respond to the natural chorus around them. The chatter of familiar species, the rustle of leaves, the call of a maytol, reinforce where they are in the world. Noises become part of the landscape. Even urban soundscapes are now embedded in the migratory memory of certain bird populations. Each of these senses wind, smell, and sound works in concert. A bird navigating across the Sahara may ride thermal winds during the day. Listen for distant mountain winds as night falls, and smell the greenery of the Sahel long before it reaches water. It's not one sense alone that guides them, but an elegant blending of multiple streams of data, refined through millions of years of instinct and learning. Young birds imprint on these cues during their early journeys. A juvenile crane flying with its parents will feel the pull of the wind, smell the changing landscapes, and hear the guiding calls. These impressions form a sensory memory like a soft map etched in their very being, that will guide them in future migrations. Some birds even adjust their migratory routes based on changes in sound or smell due to human interference. For instance, urban noise and pollution can interfere with scent-based navigation, forcing birds to adapt or reroute. This reveals the delicate sensitivity of their internal systems and the incredible resilience with which they respond in sleep. They dream in sound and scent. Scientists believe migratory birds replay environmental cues during their rest periods, solidifying memory and recalibrating direction. The brain, even in partial sleep, continues to process these inputs, fine-tuning its sense of space and place. Wind, smell, sound, each is a thread, and together they form a living map, unrolled one moment at a time as the bird wings its way across sky and season. So the next time you feel a breeze, brush your cheek, or catch a whiff of rain on dry earth, or hear the far-off coo of a morning dovry, remember that these are not just idle senses. They are the very instruments of a hidden orchestra, one that guides birds in their epic journeys from horizon to horizon. No device in their claw, no GPS on their wing, just ancient tools, and a body tuned perfectly to the song of the earth. And somewhere above, riding the wind, a bird follows the path home. Close your eyes, and imagine you are about to take the longest journey of your life. Thousands of miles, across open skies, above winding rivers and sleeping mountains, over the restless ocean. You have no map, no guide, no experience, and yet something inside you knows exactly where to go. This is the story of a young bird, a small fledgling, feathers barely dry, perches at the edge of a quiet nest. The late summer wind dances through the trees, and the golden light of the setting sun casts long shadows across the ground. Around this young bird, the older ones are already stirring. Their wings are stronger, their eyes more seasoned. They sense the season turning, and soon they'll lift into the sky. But this young one, this tiny travel is about to do something astonishing. It will rise into the air, follow the invisible thread of migration, and journey to a land it has never seen. Alone, how? This is the mystery of first flights. For many bird species, the path of migration is not taught, it's inherited. The instructions are not whispered by parents or practiced in rehearsal flights. They are written in the language of biology, encoded in DNA, passed down through generations. A map etched not on paper, but in blood, muscle, and instinct. Take the black-cap warbler, delicate songbird that migrates from Europe to Africa. Even when raised in captivity, far from the wild, young blackcaps show signs of migratory restlessness. Scientists call it zunru. At the exact time of year they should be migrating, the birds become fidgety. They flutter, they hop, they face the direction they would naturally fly. South, always south. These birds have never seen Africa, yet something deep within urges them toward it. This genetic guidance isn't just about direction, it's a full itinerary. When to leave, how far to go, even how long to fly before stopping. It's a survival strategy coded into their cells, tested by evolution over millennia. But instinct, powerful as it is only the beginning. The first flight is a first draft, a sketch. Each journey after refines the map. Birds become better navigators, with experience learning to adjust, to notice landmarks, to recognize changes in weather and wind. Their internal compass grows sharper, and in some bird families, learning comes from more than instinct. It comes from one another. Consider the cranes, in species like the whooping crane or the sandhill crane. Migration is a family affair. The young do not fly alone. They follow their parents, wingtip to wingtip, learning not just the route, but the rhythm. They are taught where to stop and rest, which valleys offer shelter, which winds to trust. These family flights are lessons written in air. And when wild cranes were on the brink of disappearing, humans had to step in. Conservationists taught young cranes how to migrate by dressing as birds and flying ultralight aircraft from Wisconsin to Florida. The young birds followed, learned, remembered, and in time they returned. That route, once lost, became theirs. It's a beautiful blend, instinct and experience, nature and nurture. Some birds rely more on inherited memory, others on living mentorship. Seabirds like albatrosses may not see land for years after fledging, but when they return, they often land on the very island where they were born. How do they find it? Scientists believe they store the magnetic and solar coordinates of their birthplace, like a home address printed in sunlight and magnetism. A memory without words. Yet, for all their wonder, first flights are not easy. They are perilous, unforgiving. Many birds do not survive their first migration. Storms roll in. Food sources vanish. Predators circle. One wrong turn can end the story before it truly begins. But even so, enough make it. Enough always do. And because they make it, the map continues. Over time, migration paths become skyways and chant routes, carved by wings, invisible highways passed down in silence. Birds memorize not just the magnetic field or the stars, but the world itself. They learn the shape of the coastlines, the hush of the forests, the glimmer of city lights from above. They carry the scent of the wind, the sound of the waves, the position of the sun. Each flight adds detail to the map inside, and though birds do not draw their maps, they pass them on, not in books or blueprints, but in survival, in success. The birds that find their way, that thrive, become parents. Their young inherit not only their genes, but the quiet advantages earned by every mile flown. Evolution slowly refines the guidance. Consider the bar-tailed godwit. This remarkable bird makes one of the longest non-stop migrations on Earth, flying from Alaska to New Zealand in a single stretch. Over 8,000 miles of open ocean. No rest, no food, no land, and young godwits, astonishingly, make this flight alone. They rise from the Alaskan tundra, join the winds, and vanish into the sky. And somehow, most arrive. They succeed not because they have done it before, but because their ancestors have. Their biology is sculpted by survival. Their wings remember the shape of the wind. It's easy to admire birds in motion. Their grace, their determination, the way they stitch lines across the sky. But what's happening inside them is just as extraordinary. A brain tuned to the planet's secrets. A body balanced on the edge of precision and resilience. A heart strong enough to carry the memory of places never seen. The first flight is more than movement. It is transformation, from fledgling to voyager, from grounded to airborne, from beginner to inheritor of something vast and sacred. And so, the next time you see birds circling in late summer, or weaving V-shapes across the pale blue canvas of fall, pause for a moment. Look closer. Some of them are flying for the very first time, guided not by maps or mentors, but by an ancient whisper deep within, a compass inside their chest, a story written on the wind, a journey born in the dark silence of the nest, and fulfilled beneath the endless sky. Close your eyes and picture a tiny bird, white and silver, with slender wings that slice the wind like poetry in motion. It weighs no more than a lemon. It could sit in your palm like a puff of air. But this little bird is about to embark on a journey so vast, so mind-bendingly far, that even we with all our airplanes and satellites can only stand in awe. This is the Arctic tern, and tonight we follow it. Our story begins in the Arctic Circle. It's summertime. A soft golden light lingers through the midnight hours. Snow still clings to the distant peaks, but the tundra pulses with life. Here, in the silence of melting ice and blooming moss, the Arctic tern hatches its young. This is where the journey starts, but not the way you might think. Because for the Arctic tern, this northern land is only half of home. It also belongs to the other end of the earth, the frozen coastlines of Antarctica. And somehow, every year, it travels from one to the other and back again. Not just once in a lifetime, but every year. Round trip, pole to pole, roughly 25,000 miles. Pause for a moment. Let that sink in. That's like flying from New York to London and back 20 times. All without rest stops, all without Google Maps. Now imagine doing that, using only the light of the sun, the pull of the earth, and a sky full of ancient memory. That's what this bird does, no bigger than a sandwich. And yet, it pulls off the longest migration of any animal on Earth, and somehow it doesn't get lost. So let's start with timing, because timing is everything for a migrant of this scale. The Arctic tern leaves the northern hemisphere just as summer fades, riding the tilt of the earth toward the warmth of the southern hemisphere. It doesn't just escape winter, it erases it. For the Arctic tern, life is an eternal summer. It lives where the sun always shines. It flies into spring like a whisper, and out of autumn like a ghost in its lifetime. A single tern may see more daylight than any other creature on the planet, and it knows when to go. Not by a calendar, not by weather forecasts, but by a rhythm deep in its bones. Its body feels the length of the day, the position of the sun, the subtle shifts in wind and scent. That's its clock, its clock. The tern doesn't need a reminder, remembers the light, and when it's time, it lifts. Wings outstretched like sails, body light as breath. It begins to glide. Southward, now here's the fascinating part. It doesn't fly in a straight line. If you were to draw the route on a map, you'd see a sweeping, S-shaped path. It loops down along the coasts of Europe and Africa. Then it curves across the wide belly of the Southern Ocean, and when it returns, it swings up through South America and back across the Atlantic. Why not just go straight? Because the tern is smart instinctually smart. This looping route lets it ride tailwinds, avoiding headwinds and storms. It's not just flying, it's surfing the sky. It knows how to glide on air currents, saving energy over thousands of miles. The Earth's atmosphere becomes its highway, and the bird reads it like an open book. Now imagine you're that bird. Below you, endless blue dot. No land, no trees, just the wind and the waves. And yet, you're not lost. How? That's the real miracle. Scientists believe the Arctic tern uses an astonishing combination of senses to navigate. It tracks the angle of the sun across the sky like a moving compass. On clear nights, it follows constellations. On cloudy days, it may detect polarized light, invisible to our eyes, but shimmering in patterns birds can see. But the most mysterious of all, magnetoreception. The Arctic tern likely has the ability to sense Earth's magnetic field and inner compass, tuned to the invisible lines that wrap around our planet. It's like having a sixth sense, one that can feel the shape of the globe. This magnetic sense is thought to live in special cells near the bird's beak or eyes. Some scientists suggest it's tied to molecules that respond to magnetism. Others believe it's a quantum reaction, tiny particles shifting as the Earth turns. Whatever the mechanism, it works, and it works over oceans, over ice sheets, over swirling winds and months of flight. The tern is not guessing, it knows. And here's what's even more humbling. Many of these birds make their first trip alone. No parents, no guides. Just a fledgling bird lifting into the wind, heading for a continent it's never seen. And somehow it gets there. No lessons, no teachers, just instinct and the memory of generations. It's not a journey made once in desperation. It's made again and again. Every year, the tern arrives in Antarctica, just as summer is beginning. It feeds on krill and cold water fish. It rests along ice-bound shores. Then, as the sun starts to dip, it lifts again and flies all the way back north, to the Arctic, to the very spot where it was born. Thousands and thousands of miles, again and again. There's a kind of sacred geometry in that. A life shaped by circles, not chaos, not confusion, but rhythm. A loop of light and shadow, a dance between hemispheres. What drives this bird to make such a journey? Why not stay somewhere easier? Maybe that's the wrong question. Maybe the tern doesn't think of it as hard or easy. Maybe it doesn't think at all in our terms. It simply is a migrant. Motion is not its choice, it's nature. The world turns, and it turns with it. We are the ones amazed, and rightly so, because in the Arctic tern, we see what's possible without technology, a kind of ancient intelligence written into feathers and bone, a map made of sky, a compass made of light. When you see one next, if you're lucky enough, pause and let it remind you, we are not the only travelers. We are not the only ones with purpose, memory, or direction. The earth holds its secrets close, but sometimes it sends them flying past us in silence, on wings as thin as breath, as you sink into stillness. Let the sky open above you, vast, beautiful, but not without its shadows. Tonight, we follow the wings that brave not just distance, but danger. For even the most finely tuned internal compass, even the most ancient map etched into brain and bone, must contend with a world full of obstacles. Migration is not a peaceful glide through calm skies. It is a perilous undertaking, a marathon, through storms, predators, pollution, and confusion. Even with no map or GPS, birds somehow know where to go, but getting there. That's the part that tests their survival. Imagine a tiny warbler, no heavier than a pencil, setting out on its first transcontinental flight. It has the tools, an internal compass, star charts written into its instincts, magnetic whispers in its blood. But on the horizon, a storm begins to build. Thick clouds block the sun. The Earth's magnetic field pulses with solar wind. the stars vanish behind gray curtains. And now the bird, once so sure, must improvise. Storms are one of the greatest hazards migratory birds face. Heavy winds can blow them hundreds of miles off course. Rain can weigh them down, soaking their feathers and stealing their warmth. Lightning crackles through clouds, and freezing temperatures wait at high altitudes. Some birds try to fly above, the weather climbing to dizzying heights, where the air is thin and freezing. Others hunker down, waiting out the worst in unfamiliar trees or urban rooftops. But storms don't always leave time for waiting. Then there are the invisible dangers ones we humans have placed in their path. City lights confuse migrating birds at night. Many species rely on starlight to orient themselves, using the constellations like ancient sailors once did. But when the stars are drowned out by light pollution, birds can spiral toward city centers, colliding with windows, glass towers, and radio antennas. Every year, millions of birds die from these collisions. To bright lights, they mistake for moon or starlight, only to meet glass at full speed. Wind turbines, too, though clean and efficient, pose a silent threat. Rotating blades can strike low-flying birds who never saw them coming. It's not the presence of the turbine, but the way it interrupts ancient airways carved by generations. And still, the birds fly, not because they know it's safe, but because they must. Some of the deadliest barriers are the ones that cannot be seen. Pesticides can poison. The insects, birds, depend on mid-journey. Wetlands once used as stopovers dry up or are replaced by shopping malls. Forests are thinned, coastlines hardened, fields turned to concrete. Imagine being halfway through your migration, exhausted, hungry, and in need of rest, only to find the place your ancestors always used has vanished. Resting spots, known as stopover sites, are vital. These are the oases in the sky where birds can refuel, rehydrate, and prepare for the next leg. When those sites disappear, entire migrations can collapse. It's not just hunger, it's a missing link in the chain. And the birds, without maps or news reports, won't know it's gone until they arrive. Predators wait on land, in the sky. And even beneath the water, sharp-shined hawkstalk flocks from the air. Foxes and cats hunt tired songbirds resting on the ground. Even fish, like bass and pike, have been known to snatch swallows as they skim too low over lakes and rivers. And then there's exhaustion for birds that fly hundreds or even thousands of miles without stopping. Sheer fatigue can be the final threat. The bar-tailed godwit, for example, flies 7,000 miles non-stop across the Pacific. No breaks, no sleep in the usual sense. Just endless wing beat. If it misjudges the wind, the weather, or its energy stores, it won't make it. There is no backup plan. Yet, even with all these dangers, natural and man-made, the miracle remains. They still go, year after year. Species after species. How? Because evolution has made them adaptable. When the stars are hidden, they listen to the magnetic field. When wind pulls them astray, they course correct, using smell, sound, and memory. When familiar grounds are gone, some find new ones, marked but necessary. Some species are even shifting their routes in response to climate change, just in departure dates, selecting alternate flyways, moving farther north or south as temperatures shift, it's not that they know why the change is happening. It's that they're finely tuned internal instruments, those ancient tools for timing, temperature, and light sense, that something is different. And so they adjust, quietly, persistently. But the challenges are growing. Climate change doesn't just alter temperatures, it reshapes wind currents, moves insect populations, and changes blooming times of plants. A bird that arrives on time may find its food already gone or not yet appeared. Timing is everything in migration. Too early, and the resources haven't arrived. Too late, and the feast is over. This is phenological mismatch, a fancy term for showing up to dinner when dinner's no longer there. For a bird, that can mean starvation. For a species, it can mean population collapse. Still, some endure, and some even thrive in the chaos. Urban birds learn to time their flights around human patterns. Some use buildings as landmarks, not obstacles. Pigeons, crows, and sparrows have become migration masters, adapting their paths, finding new routes, following heat and food in real time. But many others are not so lucky. Long-distance migrants, those who travel thousands of miles, are most at risk. They need multiple ecosystems to align perfectly. Their breeding grounds, their stopover sites, their wintering homes. If just one link breaks, the chain can fail. So why do they still try? Because they are wired to move. Because staying behind carries its own risks. Cold, starvation. Competition migration isn't just a choice. It's a survival strategy, refined by millennia. And even with all the hazards, it works more often than not. So tonight, as you lie still, and the dark wraps gently around your thoughts, think of the birds above, not just the ones soaring with grace, but the ones buffeted by winds, dodging towers, circling confused by city lights. The ones who push through hunger, who face a sky full of threat, and fly anyway. They don't carry maps, they don't use GPS, but they carry something far more powerful. Instinct sharpened by time, senses guided by nature, and a persistence born of deep memory. They are the travelers who dare the impossible every year. The small, silent warriors of the sky, and somehow they keep coming home. Close your eyes now and imagine the sky. A canvas of dusk blue, stretching forever. Now imagine that somewhere up there, a bird is sleeping. While flying, it seems impossible, doesn't it? To surrender to sleep while still moving, still migrating, still navigating. And yet, nature, quietly brilliant, as always, has made a way. Let us drift into that mystery together. For a long time, scientists believed that all sleep required stillness. That, to rest the mind, the body must be still, grounded, protected. But birds have always been the exception. Consider the alpine swiftsleek, fast, never seeming to tire. It can remain airborne for more than 200 days without landing, soaring across continents, and during that time it sleeps. Not on the ground, not on a branch, but in the air. How? The secret lies in the way their brains work. Birds have a remarkable ability, called unihemispheric slow-wave sleep. It's a long name for something beautiful. They can sleep with half their brain, while the other half stays awake. One eye closed, one eye open, one hemisphere resting, the other watching, flying, steering. It's like dozing with one foot still on the gas pedal, cruising on instinct and wind. Ducks sleeping in a row do this too. The birds on the outside of the group sleep, with one eye open, always scanning for danger, while their inner eye and brain rest in flight. It works the same way. The bird enters a partial sleep state. Not deep, not dream-rich, but enough to restore the brain, enough to survive. Now imagine being thousands of feet above ground. The sky is cool, quiet, and full of stars. Your wings beat on, steady and smooth. One eye closes. Your mind drifts, but not completely. You are still moving, still navigating, still alive. This is the sleep of migration. Not long, not luxurious, but just enough. Researchers studying the frigatebird, a seabird that can fly for weeks, found that during flight, it sleeps for just 42 minutes a day. Tiny moments of rest, scattered like feathers across the wind. On land, it will sleep up to 12 hours, but in the air, sleep becomes a whisper, a flicker, a compromise. So how do they keep flying without crashing or losing their way? The answer is as strange as it is wonderful. Their brains prioritized navigation over rest. Even in sleep, the compass inside them keeps turning. Their internal magnetic sense, the sun's position, the patterns of stars, all these continue to guide them, even while half asleep. It's as if their mind knows the path so deeply, it doesn't need full consciousness to follow it. They don't just know the way, they feel it. Think now of the common swift, a bird so light it barely disturbs the air. It hitches itself to updrafts, letting warm currents carry it higher, higher still. And in those gentle climbs, it sleeps. For a few seconds, then a few more. It's not a deep sleep, it's a dance between vigilance and surrender, like floating with your eyes half closed, listening to the wind and memory. But sleep in flight isn't just about rest. It's about survival. A migrating bird may fly across oceans, deserts, cities, with no safe place to land. No trees, no fresh water, no cover. Stopping might mean death. And so, evolution gifted them this extraordinary compromise. Sleep on the wing, recover while in motion, dream while still awake. You may wonder, do they dream, these airborne sleepers? That's a question even science can't fully answer yet. We know REM sleep, where dreams often occurs, rare in flight. Most of their sleep is shallow, alert, but perhaps in those brief flickers they remember the forests they once knew, the voice of their mother, the call of a distant coast they've never seen, but somehow already understand, because migration is memory. Memory passed through feathers and time. Even sleep cannot erase it. Birds also know when not to sleep. During key parts of the journey, when flying over mountains or dangerous seas, they stay fully awake for days, using wind and thermals to carry them. Sleep becomes optional. Survival becomes everything. And when they finally reach a safe resting place, they collapse into deep, uninterrupted sleep. A sleep they've earned with every wing beat. Now close your eyes again and imagine it. A sky filled with travelers, each one tracing invisible roads across the stars. Some awake, some half dreaming. All moving forward, they carry no map, no satellite signal, no GPS chirping in their ear. And still they find their way, even while asleep. It's not just a marvel of biology, it's a miracle of trust. trust in their bodies, in their instincts, in the ancient wisdom etched into their very bones. So tonight, as you settle beneath your own soft sky, know that you share the night with sleepers in motion, with minds half awake and hearts fully committed. Birds who never stop, not even to sleep, unless they can sleep and fly at once. Their journey is long, their world full of wind and risk. But still they go, still they soar, still they dream, just enough, and perhaps tonight, so will you, so will you. It stretches endlessly, above, clear, open, eternal. For most birds, this is a road they know without ever seeing. But sometimes, even the wisest wanderer strays. Tonight, we follow the ones who drift off course, the lost flyers, the scattered feathers, the quiet detours in nature's perfect map. Let's fly with them through fog, through storms, through the strange silence that follows the moment a bird realizes something isn't right. You may think that birds never get lost, that their ancient instincts, sharpened over millions of years, make them immune to confusion. But even the best navigators can stumble, not from weakness, but from the sheer complexity of the world. Migration is not a straight line. It is a moving maze, one that changes every year. Imagine you're a young warbler on your first journey south. You're following the stars, just like your parents did, just like their parents before them. But tonight, the sky is clouded. A storm rolls in. The stars vanish behind velvet. Wind tosses you east instead of south. You fight to reorient, but the wind insists. You land when the rain allows, only to discover you're far from the flock. The forest smells different. The insects don't sing the songs you know. You're lost. So how does a bird lose its way? There are many culprits, whether pollution, urban lights, geomagnetic disturbances. A sudden thunderstorm can shove a bird hundreds of miles off course. A city skyline full of bright lights can confuse their star compass, tricking them into circling endlessly. And then there's the Earth's magnetic field, a guide that most birds follow. But sometimes solar flares or geomagnetic storms disrupt that inner compass like static on a radio. The bird is not broken, just temporarily blinded. Some birds adjust, they recalibrate. They find a river, a coast, a wind current that feels familiar, and they begin again. Others aren't so lucky. Each year, thousands of birds are spotted in places they should never be. These are called vagrant avian wanderers, far from home. A hummingbird meant for Mexico shows up in Nova Scotia. A European songbird lands on a Florida beach. To us, it's a marvel. To the bird, it's often a quiet crisis. Why do some birds get so drastically lost? For young birds, it's often a navigational glitch. Their compass works, but they misread longitude or directional angles. Instead of flying southwest, they go southeast. It's like entering the right password with one letter off. The result is confusion, unrecognizably, even dangerous. Then there's a phenomenon known as mirror migration. Some birds don't just take a wrong turn, they reverse their direction completely. Biologists believe it's often genetic and inherited miscode. They fly with perfect confidence, in the wrong direction, but getting lost isn't always tragic. Sometimes it creates new discoveries. When enough birds of one species consistently veer off path and survive in a new place, they may begin to settle there. Over generations, a new migration route can be born accidental at first, but eventually intentional. This is evolution on the wing, improvisation in slow motion. Now, think of the Arctic. Turn again, the globetrotter, who travels from pole to pole. Even this expert can drift off course when the Earth itself shifts. Climate change has redrawn coastlines, dried up lakes, pushed prey farther from reach. And when the food moves, so must the birds. But for some, the new path is full of unfamiliar cues. They rely on memories passed down through generations. But now, the land beneath those memories has changed. The roadmap is fading, and they must learn again. Some birds use smell to reorient. They follow odors on the breeze, like reading a story in scent. Others search for landmarks, a mountain ridge, a river bend, a pattern in the forest canopy. Slowly, step by step, they stitch together a new way forward. But not all return. Sometimes being lost means being found. By us, you might hear a strange song in your backyard one morning, a call you've never heard before. And there it is, a tired, thin, wide-eyed bird. Far from where it belongs, birdwatchers call these moments fallouts or rarities. To them, it's a treasure, but for the bird, it may be the final stop. Or, if it's lucky, just a pause, with rest, water, and time. Some find their wings again. There's something poetic in this, isn't there? That even nature's finest travelers can lose their way. That migration is not perfection, but a balancing act between instinct and chance. They don't carry maps. They don't ask for directions, but they move forward anyway. Even when lost, they are still in motion. And perhaps that's the lesson we take with us tonight. To be lost is not always to be doomed. It can be a pause, a pivot, a chance to feel the world in a new way. Birds do not fear being off course. They rest, they wait, they listen. And when the sky clears, they fly again. So close your eyes now and picture the dark outline of a bird gliding alone across the clouds. Not where it meant to be, but still aloft. Still carried by wind and memory. May you too always find your sky. Even when the stars disappear. Even when the map is gone. For the heart knows the way. Even when the path is lost. Not the sky you knew yesterday, but one that's just a little warmer, a little wetter, a little less familiar. The winds shift, the temperatures rise, the ice thins, the seasons blur, and high above, the birds begin to notice. This is not the sky their ancestors flew through. This is something new. And so, the paths they once followed must change. Tonight, we float on soft wings through the gentle chaos of a warming world, where even the most ancient migrations must learn to adapt. For millions of years, birds have flown with exquisite timing, each migration matched perfectly to the planet's rhythm. Spring blooms, insects hatch, rain falls, seeds scatter, and just as the earth opens its arms, the birds arrive. But what happens when spring comes too early, or rain comes too late? When flowers bloom before the pollinators arrive, and food appears, then vanishes. The birds are still arriving, but the welcome is no longer the same. Climate change is not just a story about temperature. It's a story of mismatch. Imagine flying thousands of miles, only to discover the feast you depended on has already come and gone. This is called phenological mismatch, a fancy phrase for a simple tragedy. The clock is ticking faster, but the flyer hasn't caught up. Birds time their migrations using fixed cues, daylight length, sun position, magnetic fields. But climate change alters the world in ways those cues don't reveal. And so the birds follow their compass, only to find the world beneath them has shifted. The Arctic is warming faster than almost anywhere else, and the birds who nest there, like the red knot and snow bunting, are running out of runway. Their food tiny crustaceans, blooming moss, insect hatches. Timed to snowmelt is now peaking too soon or too late. Chicks hatch hungry, but find too little to eat. Some survive. Others vanish quietly into the wind. Farther south, wetlands dry. Storms grow stronger. Coastal breeding grounds flood. Birds like the black skimmer and least tern return to beaches that no longer exist. Their nests' shallow scrapes in the sand are swept away before the eggs can hatch. Others meet heat waves in their desert stopovers for droughts where lakes once shimmered. The journey that once depended on consistency now demands flexibility, and not all birds can adjust in time, but some can. The barn swallow, once nesting only in temperate zones, is now flying farther north. So is the great tit and the chiffchaff, and many species of warblers. Even the blackcap, a small European bird, has begun wintering in the UK rather than Africa, choosing a shorter flight, and arriving to a warmer winter. Migration, in these cases, is evolving. Routes are redrawing. The birds are writing new maps on the fly. But such flexibility has a cost. Shorter journeys may help survival, but also change ecosystems. Birds arriving early may outcompete others, or miss their former partners in pollination. The air becomes a puzzle with old pieces missing and new ones trying to fit. Each migration is no longer just a passage, but a test of improvisation. Let's float back now to the Arctic tern-hour long-distance flyer, gliding between the ends of the earth. This bird depends on cold oceans, teeming with plankton and small fish, but the oceans, too, are changing, acidifying, warming, currents shifting, and though the tern still flies 44,000 miles, each year its certainty is no longer guaranteed. The sea beneath its wings holds different answers now, and yet there is hope. Some birds are learning. They're delaying migration until the last moment, responding to real-time changes in temperature. Some are shifting their diets. Others are nesting earlier or later, timing their journey to the changing buffet of life. Even their bodies are adapting. Birds in some regions are evolving longer wings, more efficient muscles, lighter frames for longer flights. Evolution is whispering, guiding them step by step into the future, and we too are learning. Scientists now track birds with satellite tags no bigger than a paperclip. We map their changes. We study their detours. We listen. Citizen scientists around the world log sightings. People hang bird feeders, plant native trees, restore wetlands, shade their windows. We are beginning to understand that their sky is our sky, too. And when it warms for them, it warms for us. So what does it mean when a creature that once knew the way no longer does? It means the world is writing a new song, one with new rhythms, new pauses, new notes in unfamiliar places, and the birds, those age-old singers of the sky, are learning to hum along. Migration is no longer just a journey of memory. It is a journey of adaptation, of flexibility, of resilience in the face of rising tides. They still fly, not because the path is easy, but because the urge is unshakable. The instinct endures, even when the world beneath it does not. Close your eyes now, and imagine a sky that is learning itself again. Imagine a bird on the wing, searching for home, and finding it not by map, but by heart. Let that be your comfort, that even in a changing world, some will always try to find the way, and many will succeed. Close your eyes now and imagine the sky, but not just any sky. Imagine one filled with motion. Thousands of wings slicing the air, each feather catching wind like a sail of memory. There's no traffic light, no signposts, no voice from above whispering directions. And yet they move as if guided by a song only they can hear, a deep ancient music, played not with instruments, but with instincts and memory. Tonight, we drift into that invisible symphony, the one composed not of notes or sheet music, but of wind, starlight, and stories passed down from one beating heart to another dot. How do birds remember the way? Some of it is hardwired, baked into the very shape of their bones. From the moment they hatch, many birds are born with a map encoded inside them, a sense of direction, a timing of departure, a knowing of where the world will welcome them. But memory adds more as birds grow. They begin to collect impressions, landmarks, smells, air pressure changes, sun angles, sounds of rivers, the curve of a mountain range against the horizon. Each migration writes a layer, each journey leaves a trace, and over time, those traces become a memory map, not a map with names or grids, but a living one, fluid, responsive, alive in the mind. Swans have been seen flying the exact route their parents once showed them, turning over the same ridges, gliding down the same valleys. Sandhill cranes pass routes down through generations. Young birds travel with adults, their first season watching, learning, remembering. Who taught them? The sky, the earth, each other. Imagine being a young bird on your very first migration. The world is wide, your wings still unsure, but then you see the others, hundreds flying ahead, calling out a rhythm, and so you follow. That first journey becomes a memory, and the next year you follow it again, not just by instinct, but by experience. The wind feels familiar. The mountains are old friends. The curve of the coastline tells you you're on the right track. It is memory that gives confidence to the journey in pigeons. Even city pigeons, memory plays an extraordinary role. Some can return home from hundreds of miles away, not because they were told where home is, but because they remember the route, a visual sequence of landmarks, from the sky, fields, bridges, buildings, even smells in the air, like a melody, playing quietly in their minds. They follow the familiar notes, and the Arctic tern, our globe-spanning flyer, may remember oceans and currents as patterns of sound and taste. aligning them with magnetic signatures stored in their internal compass. Memory becomes not just a tool, but a safety net, a way to reduce surprise in a world full of change. Some birds even remember stopover points, the resting oases along their path, a pond in a desert, a fruiting tree beside a highway, a barn roof where they once caught their breath. These places stay in their minds. Some birds return to the exact same tree, year after year after year. And so the route is not just a line, but a story, with chapters and resting points, a narrative written across the earth. There's another kind of memory, too, the kind held not by individuals, but by entire species. It's called cultural memory. Think of cranes who, over generations, alter their routes together, remembering where dangers once were, or where food grew abundant. Not every bird needs to survive each journey. As long as enough of them remember, the path is preserved. Even when an elder is lost, the flock carries the music forward, like a song passed down from beak to beak, wing to wing. But memory, like music, is not always perfect. When the world shifts too quickly, when forests disappear, or rivers dry up, or new cities rise, then memory can lead them astray. A remembered pond may now be a parking lot. A safe hill may now hold a tower. And so memory must evolve. Some birds learn new routes, others follow new leaders. The flock becomes a classroom. The sky becomes a chalkboard. They adapt, they adjust, they write the next chapter together. Scientists, today, study these journeys with quiet awe, using tiny GPS trackers, radar, and sound recorders. They map what the birds already know, and in doing so, they're beginning to understand that migration isn't just an act of movement, but of wisdom. Each feathered traveler holds inside them a piece of the planet's memory. The wind carries stories, the stars remind, the landscape whispers. So tonight, as you float deeper into stillness, know this. High above, thousands of wings beat against the dark, not lost, not random, but guided by a quiet symphony of memory and instinct. They return, again and again, not just because they know the way, but because they remember how it felt to find home. And that is something we all understand. Close your eyes now, and imagine the sky. It looks still, doesn't it? A canvas painted in blue, gray, or deep velvet black. But hidden in that stillness is motion. Wings gliding over continents, beaks slicing through wind, heartbeats that never lose the rhythm. Birds migrate some thousands of miles without a single map, without any GPS. But we humans, we've always wondered, where do they go? How do they know? And how can we follow them without wings of our own? Tonight, we turn our gaze not just to the birds, but to the long and curious journey of how we humans learned to track these invisible travelers. Long before we had satellites or science, we watched shepherds, sailors, monks, peasants in fields. They noticed when the swallows vanished, when the geese returned, when cranes passed overhead with the change of seasons. To early humans, birds vanishing into the horizon seemed like magic. Where did they go in winter? Did they fly to the moon, sleep under the ocean, transform into something else entirely? Aristotle, the Greek philosopher, once suggested that swallows hibernated in mud. It sounds strange now, but back then it was a mystery wrapped in feathers. Then came the patient watchers, those who didn't just guess, but began to take notes. By the 1700s and 1800s, naturalists across Europe and beyond began keeping journals. They noted when storks appeared, when songbirds returned. They compared dates, noticed patterns, realized these migrations were real, regular, and astonishingly far. But how far, and where exactly? We needed more than eyes. We needed ways to mark the travelers. That's when something beautiful happened. In the early 1900s, scientists began banding birds. A tiny numbered ring placed gently on a bird's leg. Asterisk if the bird was caught again elsewhere. They could trace its journey. It was like mailing a letter with no address and waiting to see where it ended up. And the results? Stunning. A white stork banded in Germany was found in Sudan. A swallow tagged in England was recovered in South Africa. Suddenly, migration wasn't just a theory. It was a global voyage, a loop that tied continents together through wings and instinct. Still, banding had its limits. He had to recover the bird to read its tag. What about the ones who never returned? What about the invisible days in flight? We needed new tools, and so we built them. In the mid-1900s, radar became one of the first great leaps. Originally built to track planes, scientists realized it could track birds, too. In spring and fall, the screens lit up. Waves of life flying overhead. No more guesses. Now, we could see the flocks as they moved, even on the darkest nights later. In the 1990s and early 2000s, something smaller and smarter arrived. Radio telemetry and satellite tags. Tiny devices, some no bigger than a peanut, attached to a bird's back or tail. The bird would fly, and the signal would beam to space, then return to scientists on the ground. We began to see individual journeys. A curlew flying from Alaska to New Zealand. A bar-tailed godwit soaring 7,000 miles non-stop. Each flight became a story, each signal a sentence, and we, the readers of the sky, began to understand the language of migration. Then came geolocators, even tinier devices that used sunlight to estimate location, and more recently, GPS tags, so accurate they can tell us when a bird takes a left turn over a forest. Imagine that, knowing a bird's position within meters, half a world away. But even with all this tech, the magic hasn't faded. If anything, it's grown deeper, because now we don't just know where birds go. We begin to glimpse how they do it, how they time their flights with the wind, how they rest, drift, and navigate, how they sense magnetic fields or follow stars. Our tools helped illuminate their ancient wisdom. But tracking isn't just for curiosity anymore. It's also a lifeline. Climate change, habitat loss, city lights. These threats are real. And with every tag, every signal, we can see how birds respond. Do they change their routes, delay their departure, find new homes? With that knowledge, we can protect migration paths, preserve stopover sites, make choices that keep the sky safe for wings. Sometimes, school children help track birds. In classrooms around the world, students watch satellite maps, following a goose or a tern across oceans. They cheer when the bird arrives. They worry when it lingers. That connection between a small human heart and a distant migrating bird may be one of the most powerful things we've built, because understanding creates empathy, and empathy, in turn, creates care. So now, imagine again the sky, but this time see the invisible threads we've drawn across it. Each bird in flight, not just a dot in the distance, but a point on a map we can finally read. We may not fly with them, but we walk alongside their journey in data, in graphs, in glowing screens. We are the watchers, the witnesses, and in doing so, we remember something we had long forgotten, that the world is not divided. It is connected by feathers, by flight, by the rhythm of return. So rest easy tonight, knowing that even as you sleep, there are birds sailing across stars, and scientists watching quietly, tracing each gentle heartbeat across the globe. And you are part of the symphony now, because to care is to listen, and to listen is to love the sky just a little more. Somewhere up there, a bird is heading home, and in that journey, there's a lesson waiting just for you. Tonight, let's drift gently into the heart of that lesson. Let's explore what birds, those silent sky travelers, teach us about the meaning of home. You see, for a bird, home is not always a single place. It can be two places: the breeding ground, where life begins, and the wintering ground, where life is sheltered. To a swallow, home might be a quiet barn in England during summer, and a green valley in South Africa come winter. To an Arctic tern, home stretches from pole to pole, from frozen cliffs of the north to the sunlit edge of Antarctica. They are not confused. They do not forget. Their bodies remember the way, and their heart-sift birds have hearts like ours, recognize the feeling of arrival. And isn't that what home really is? Not just coordinates, but a feeling. Imagine flying thousands of miles, crossing deserts, dodging storms, navigating by stars and scent and the whisper of wind. And then one morning you see the bend in the river, the curve of a tree branch, the light hitting the rocks just right, and your body sighs. Because you've made it. That moment, that breath of knowing, is something birds feel too. And maybe we do as well. Birds teach us that home is not always where we stay, but where we return. That there can be more than one true home in a lifetime. That it's okay to move, to shift, to change, and still carry home within you. Their migrations whisper that familiarity is found not only in place, but in rhythm. The rhythm of seasons, the rhythm of wind, the rhythm of return. And in that rhythm, there is trust. You might wonder why go through the trouble. Why fly all that way? Why not stay in one warm place? But the bird's answer is quiet and deep, because home is not always about comfort. It's about meaning. It's about growth. They return to breed, to raise young, to sing old songs. In the same trees their ancestors knew, they return to complete a cycle, not for safety, but for purpose. And perhaps you too have places like that, places that shaped you, places you outgrew, but still hold in your chest like a map made of memory. There's something else. Birds teach us that it's okay to leave home in order to find it again. Their migrations are a dance between departure and return, between seeking and settling, between risk and refuge. And isn't that the human journey, too? We leave the familiar for school, for love, for work, for the ache of something bigger. And then one day we find ourselves circling back, not always to the same house, but to the same feeling, to a sense of belonging, to a quiet that says, "You are known here, you are safe, you can rest your wings." Sometimes birds build new homes. A swallow might shift from a forest to a barn. A goose might take to city parks when wetlands grow scarce. Adaptation isn't failure, it's wisdom. So if your home has changed or vanished or needed rebuilding, you are not lost. You are migrating. You are learning to read a new sky, and that, too, is part of the flight. Some birds return to the same tree year after year. Others are guided by memory, written not in sight, but in smell. Magnetism, a low, inaudible hum that sings beneath the world. They find their way back by something deeper than logic. Maybe that's what we're doing, too. Returning to people who feel like home, to books or scents or cities that stir something forgotten inside. Not everything needs explanation. Sometimes feeling is the compass. Birds don't mourn what they leave. They follow instinct. They trust the journey, and they rest when they need to. A goose flying in V formation takes turns leading. Then, falling back to restore strength, they share the burden, and in doing so, they all go further. So maybe birds also teach us how to build home with others, to lean on one another in flight, to make space for someone tired to glide in your slipstream a while. Even now, as you lie still, the world above is full of motion. Somewhere high, a sandpiper is crossing the ocean. A duck is gliding between clouds. A warbler is scanning stars, quietly steering its body across hemispheres, and none of them are lost. They're going home, in a way only they can understand. And you're going home, too. Maybe not in miles, but in memory, in dreams, in the slow, steady return to who you truly are. So rest now. Let the sky cradle your thoughts. Let the birds carry your worries for a while. You are safe. You are loved. And even when you don't know the way, some part of you remembers, because just like them, you were made for the journey. You were made to find your way back, and that is what birds teach us about home. Close your eyes and take one last flight with me, not with your wings, but with your wonder, not through the air, but through the gentle folds of your thoughts. We've journeyed together, across oceans, over mountaintops, through starlit skies and magnetic fields, into winds scented with memory, and the quiet pulse of instinct. You've watched the Arctic tern chase summer across the world. You've soared with geese, felt the pull of ancient roots, and listened to the compass that beats softly in a bird's chest. And in those stories, perhaps you found something of yourself, a forgotten dream, a longing for home, or the calm reminder that even without a map, you are still on your way. Birds don't carry baggage, they carry trust. They don't chase perfection, they follow the sky. And now, as the night wraps around you like feathers, you can let go. To dot, let go of the noise, the pressure, the weight of needing to know everything. You don't have to have it all figured out. The birds don't, and yet they fly. So wherever you are tonight, beneath city lights, or far in the countryside, or somewhere in between this, the sky is always above you. The path is always beneath you, and you are never alone. Just like the birds, you are guided. By memory, by instinct, by wonder, by something inside you that quietly knows the way. If this journey has brought you peace, If the wings of these stories helped you rest, let us know. Leave a gentle comment below. Tell us where in the world you listened from, what part of the sky you call home. And if you haven't already, please like this video, subscribe to Science for Sleep, and share this story with someone who needs a little peace tonight. There are so many more wonders to explore together. Until then, may your dreams be light, your heart be steady, and your spirit always remember you. Two were made to fly. Good night. Good night.